Okay. Oop. Yes. Okay, great. So we've already got a couple of attendees in here. Thank you guys for being here. We're going to just give it 3 more minutes for other people to attend. If you have any questions or anything, I'm going to switch this to allow to talk. So make sure that you're on mute if you if you don't want to talk, because I'm going to give you permission so that you can ask questions. All right. Everyone who's in here, I'm going to allow you to talk. So put yourself on mute if you're not yet ready to talk. And that way, when we come to the question section, you'll be all set up. Okay, we want to start right on time. So welcome to, I believe, the 3rd installment of our LIL speaker series. We are going to hear about the day in the life of a firmware engineer. We have, thankfully, James Zhang here to tell us, everything that we need to know. So he holds both bachelor's and master's degrees in computer engineering from UCSD, where I'm sure most of the people who eventually watch this video will be interested in. And he currently serves as a firmware engineer at Schneider Electric, developing firmware for the TriConnect system, a critical safety and control solution used in high hazard industries. So we are here to benefit from his expertise, and this will be available as well after the webinar. James, I'm going to hand it over to you. I'll let people in as they arrive.
Okay, sounds good. Thank you so much, Evie. All right, so let me share my screen. Can everybody see? Is it coming up?
Yep, looks good.
Okay, yeah. All right, so hello everyone. My name is Mingqi Zhang. First, let me quickly introduce myself. Well, Evie has kind of did already. But so I graduated from UC San Diego with a bachelor's degree and a master's degree in computer engineering. After that, I have been an Android application developer for a little while, which was fun. I currently work as an embedded firmware engineer at Schneider Electric. So today, I'll be talking about a day in the life of a firmware engineer. So first, let me share a story about some conversations that have happened many, many times. So when I go out and meet new people, they often ask me this question: what kind of job do you do? So I respond with, oh, am I embedded firmware engineer? And then they usually ask, Okay, sounds cool. What is that? So to make things easier, I would just correct myself and say, well, basically, I am a software engineer, so I write software, but the software runs on a circuit board. Most of the time, they understand a little bit better, but still not completely. Firmware and software are somewhat alike, but there are some fundamental differences between the two. So, I want to first spend some time to explain what software is, what firmware is, and how they are different. Sometimes you might also hear the term embedded software, which in most cases is interchangeable with firmware. The term embedded emphasizes that the software is running on some specific hardware that carry out certain operations. So let's first talk about what software is. Born in this digital age, I believe many of you have already been exposed to a great number of software applications. Some of them are PC applications like Microsoft Word, Chrome browser, Photoshop, and so on. Others might be running on your smart devices like your smartphones, your iPads, or smartwatches. For example, apps like Amazon, Instagram, TikTok, and so on. These are all software or software applications. Now, what is firmware? The term firmware was coined by Asher Opper in a 1967 Datamation article as an intermediary term between hardware and software. So, in simple terms, firmware is essentially software that controls the hardware or the circuitry found in almost every electronic appliance. For example, if you want to heat some food in the microwave, you set the parameters like time and mode, and then turn it on. It's the firmware in the microwave that controls how it functions and heats up your food. Another example is in the factories. The robots or robotic arms that are used in factories to manufacture all kinds of goods rely on firmware to perform their designed tasks. If we compare software and firmware, there are similarities between them. Any kind of software or firmware consists of three parts: the input, the processing, and the output. The processing step is similar in both, which occurs on either a microprocessor or a microcontroller. That's where information, either gathered from software or hardware, gets processed, which is why both software and firmware engineering involves programming. However, the core of software is mostly data or information. So the form of input, processing, and output all takes the form of information or data flow. The purpose of software is usually the gathering and processing of information for the ease of human use. While on the other hand, firmware systems are often used to control machinery or to impact our real world. So the input and output usually comes from real hardware devices, which are often sensors and actuators like temperature sensors, humidity sensors, motors, and so on. So, besides that, here are some key aspects that are unique to firmware when compared to software. The first thing is not all functions of embedded software are initiated or controlled via a human interface, but through machine interfaces instead. A simple example would be a printer. For the most simple and basic printers, it is very easy to use. You just need to power on the printer, connect a cable from your PC to the printer, open up your document, and then hit print. There you go. The printer just gets everything from the computer and prints it out for you. You don't have to interact directly with the printer to get the printing done. This is all made possible by the firmware running on the printer. Another aspect is that it is always running. So think of a typical software. You open your computer or your smartphone and you want to search for something on the internet. So let's say you open your browser, go to Chrome or whatever, or go to Google or some other search engine where you type your keywords and then hit enter. So from there, you get whatever information you need, and you're like, okay, now I found what I needed. So what do? You close the browser, and then it just stops running. But for firmware, once you power on the device, it starts running and will keep running until it is powered off. Or when it breaks, which hopefully never happens. For example, the control system in your car starts running when you hit the ignition button, and then all the control systems in the car keeps working throughout your drive to ensure both your safety and comfort. They run continuously until you stop the car and turn off the engine. So another point is that firmware is deadline driven. It needs to complete the task and respond before a certain deadline or in a timely manner. Imagine that you're writing a document. You open up Word, type something, and then try to save it. Now, all you see is that your mouse becomes a spinning circle, and then the window is not responding. What do you do now? Well, maybe you wait for some time, have your fingers crossed, and then hopefully it comes back. And eventually it does come back, and your work is saved. Phew. But sometimes it doesn't come back. In this case, sadly, you'll have to force stop the program and start all over again. Maybe it just takes some more effort. But now let's imagine if you're on a plane. You're flying 30,000 feet above the ground. Suddenly, the control system on the plane stops responding. You will be terrified because the non-responsiveness of such a system would lead to a catastrophic result. Well, this is a bit of an extreme example, but it does illustrate the difference between firmware and software. Now, with that being said, let's look at what software engineers and firmware engineers do. So first, let's talk about some common job duties for both. Usually, the workflow for both software engineer and firmware engineer goes like this. There will be a discussion upfront, which we call grooming, where the team gets together and have a discussion and decides what features we want to implement in the software or firmware. This is usually driven by customer needs. Once that is fixed, then we start to program, which we call implementation. During this process, there will be a lot of back and forth between programming and testing. And that's when debugging happens. We need to test that what we implemented is working correctly. And if something doesn't work, we need to go back into the code, find out what's wrong, and then fix it. And trust me, even for the most senior developers, almost nobody writes bug-free code the first time. And finally, after extensive testing and making sure that everything works, we check in our code. And good job, one task completed. Now the question is that everything that you do as a software or firmware engineer? The answer is actually no. Being a software engineer or firmware engineer involves more than just coding. There are also all sorts of other things to handle. I'm pretty sure you all have read some kind of user guide or manual or sometimes patch notes. Ever wondered who wrote those? That is also part of what engineers do. When we build a product, we need to teach other people how to use it. Especially if it's a new product, then pretty much nobody except for the developers know exactly how it works. So the developers, along with the customer service team, well, who are usually better at writing, will create a clear and easy to understand manual so that people can understand how things work and how they're intended to be used. If something is misused, well, at best, it's just not going to work. but at worst, it can cause serious problems. For software applications, your important data can be deleted or leaked. On the firmware side, if heavy machinery is misused, it might cause injuries and even death. That's why it's very important for the people who develop them, who know exactly how they work, to document it and let users understand. This is what we call external documentation. There are also internal documents, where the purpose of these documents is to communicate effectively and timely to the team members who might be working on the same part or a different but related part. These documents will help your colleagues to understand how your code works so that they don't have to go through your code themselves to find out. So, becoming an engineer does not exempt you from writing. And as a STEM student, that's a hard lesson that I have learned. Finally, there would be other miscellaneous things that you need to deal with occasionally, like helping other teams, hosting visiting customers, or updating your work progress regularly, and so on. Now, let's talk about what is different. One of the differences is the design considerations. When we compare software and firmware design considerations, because they have different operational environments and objectives, the factors that we need to take into account are different. Software design is typically focused on user interaction, scalability, and compatibility across various platforms and devices. So the designers must consider a wide range of user scenarios, ensuring that the software is intuitive and accessible while maintaining robust security. And updates and patches are very frequent, which means the software needs to be designed in a way that is easy to be modified and easy to be enhanced. On the firmware side, design revolves around stability, efficiency, and timely responsiveness. Since firmware often operates within constrained hardware environments, designers prioritize optimizing code for speed and robustness. The first firmware must be reliable over a very long operational period, as updates are less frequent and harder to do. Safety and fail-safe mechanisms are also crucial, especially since firmware typically controls critical functions in embedded systems like medical devices or automotive control systems. So you don't want anything to fail. Another difference is the knowledge about hardware and the usage of hardware tools. In software development, it usually happens using an integrated development environment, or IDE, which is built on top of an operating system and has many tools integrated for development. This makes testing and debugging very simple. In order to test the software, one can just run the code and see the output. If it is not as expected, then we can always add print statements in between or set breakpoints to find out where and why something is not correct. However, remember, firmware usually doesn't have a graphical interface. The firmware talks directly to the hardware, which is the circuitry around the microcontroller. And this often makes debugging very difficult. The first thing we need to figure out is usually whether it is a hardware problem or a firmware problem. We need to rely on external hardware tools like multimeters and oscilloscope to see what exactly is going on with the hardware. This brings us to another difference. So during the pandemic, the software industry didn't take as much of a hit as the physical industry. This is because the development of software only requires a PC for the most part. That grants the software engineers the option to work from home and still be productive. However, firmware engineers do not get that kind of luxury, as firmware testing requires hardware. For my work, I need to go into the lab to run my test on a real system and see how it behaves to verify that my code is working. So now I will briefly introduce what I do as a firmware engineer at Schneider Electric and how the professional environment feels like. So at Schneider Electric, we make a system called Triconics. Our systems are deployed in industries that has a very high risk, such as oil refineries and chemical plants. If any accident happens in such plants, it's going to cause a serious and irreversible damage to both humans and the environment. So our systems are deployed to monitor important factors to ensure that everything is working correctly. And if the system detects any issues that could lead to dangerous situations like explosions, it has the ability to automatically shut down the plant and to prevent any accidents. This not only helps maintaining operational safety, but also ensures that these industrial settings comply with with strict safety regulations. Because we're making safety products, we have a very rigid coding standard. And on top of that, we need to follow and satisfy some international standards. Coding standard is something that's internal, which guides us to write clean, easy to read code and makes it less likely for us to write code that has errors. Besides that, the code we write must also pass a code review, which is basically by another developer by adding another pair of eyes. This is to ensure that any issues that are not noticed by the person who wrote the code gets caught so that it does not create a huge problem later. And on top of that, we also need to meet international standards and are subject to audits from certification organizations. Every product that we make that is safety related has to be certified by these organizations before it can be sold or deployed. This step is also there to ensure that our products meets the safety standards. Therefore, our work involves not only implementing specific functions, but also making sure that they satisfy the strict requirements. And speaking of the environment, one very important aspect of working as a firmware engineer is teamwork. Remember, no one is a one-man army. And this is one of the reasons why I love working in such an environment. You can always count on your colleagues to have your back. Like I said before, the firmware is tightly coupled with hardware. So as a firmware engineer, we need to work with the hardware engineers. They will build the boards, make sure that the circuitry is working, and then help us fix the board when things don't work. Sometimes we make some silly mistakes in the firmware, and unfortunately, sometimes it will burn up the components. Now, who do we go to? The hardware guys. They would just take the boards, repair them, and never blame us for burning the board. And we do the same thing in return. Sometimes when things don't work, it's because of an issue in the hardware design. Now, the problem is hardware is not as easy to change as firmware. It takes a long time to change the hardware design, and then you have to send it out for manufacturing. So it really takes a long time to get the new circuit boards. Sometimes we would just take a look at the problem and say, well, okay, maybe we can make some adjustments in the firmware to fix this. And if a simple change in the firmware can make things work, it just makes everybody's life easier. So the bottom line is, every team works closely and support each other to lock down the problems and solve them. This is how we make things work. And hardware team is not the only team we work with. We also work with the software team who writes the software that runs on the PCs. We use those softwares to configure their system, to put in the programs that define how we want the systems to behave. And we need to understand what the software sends and carry out what is requested precisely. Another team that we work with is called VMV, or Verification and Validation. They are the testers who make sure that our system behaves exactly as we want it to and catch the problems that we failed to see during development. In a professional environment, everyone is dedicated to their work and everyone supports each other whenever needed. So the next question is, okay, I am now a little bit more interested in becoming a firmware engineer. How do I become one, and where can I use my knowledge to make an impact? So, in order to become a firmware engineer, you will have to learn a broad spectrum of different skills. Programming, of course, is the most important skill that you need, but it is also the most basic one. You can start with any programming language, whether it's C, C++, Java, or Python. Which language you pick doesn't matter. What matters is the way of thinking and learning how programs work. Then you also need a solid understanding of electrical circuit analysis. As I said before, firmware relies on hardware. So you'll learn how electrical circuits work and how to analyze them. Another very important area is digital systems, which covers the basics of digital electronics, including how digital circuits and logic gates function. The last thing is the hardware interfacing and communication protocols. It is also very essential for understanding how different communication protocols work. That's how different hardware components communicate with each other. So for all these topics, there are courses that are taught in most colleges if you pursue a computer engineering degree, and then they will provide the foundational knowledge necessary for you to become a firmware engineer. So besides the knowledge part, one thing that is also very important is internships and hands-on experience. Let me share a funny story about myself. So this applies to not only firmware, but also all other fields. So a lot of times when I try to learn something new, I would just go online and type in Google, whatever subject, tutorial, video. Then I would be sitting there and then watching people talk about how to do this, how to do that. And I'll be like, okay, I have learned something new today. And sometime later, when I actually face a project that requires that particular skill, one of two things would happen. So either I partially or completely forgot about what I've learned, or the actual situation is different from what I had learned in the video. So my point is, the best way to learn things and be good at them is through hands-on practice. So try to do an internship or some kind of hands-on project. I would definitely recommend going to labs in colleges. Don't be shy. Just walk up to the professor that you like and kindly ask them, hey, I'm really interested in this topic. I want to learn what you do. And do you have any project that I can learn from or maybe contribute to? Or if you think you have a brilliant idea, gather some friends. Ask them if they are interested in collaborating with you on a project. As I mentioned before, teamwork or the ability to work with others is very important in the industry. So now, as a future opportunities, because firmware is a versatile skill, it is used in various industries and sectors. Therefore, becoming a firmware engineer offers many possible choices for your career development. And here's an important concept to understand. Job and industry are two different things. Your job determines what you do every day, while the industry determines where your work is applied. As mentioned earlier, firmware has a wide range of applications, such as in medical devices, household appliances, automobiles, and so on. The medical robotic arms need the firmware to work precisely to treat the patient. Smart home devices can make your daily life more comfortable, or if you're very ambitious, hey, they need a firmware engineer to build the rockets. Or maybe you will even come up with the next $1 million idea, which uses embedded systems in a way that has never been used before. All I'm trying to say is, wherever electronics are involved, firmware is needed and is very critical. So looking to the future, areas like the Internet of Things, electrical vehicles, clean energy trends, which are mostly electricity based, will all become valuable areas for embedded firmware. Anything that uses electricity will require electrical control systems, which is what firmware does. So the bottom line is, you can literally do anything. So what are the challenges and rewards for going into this field? The first challenge comes from getting into this field, or the learning curve. When you first start, you'll be very confused. And this confusion does not come from not being able to learn any specific knowledge. Whether it's programming or circuit analysis, trust me, these skills are not that difficult to learn. And even if you find it very difficult when you are learning something new, eventually it will just become natural to you after some time. The real difficulty is to connect the dots. In my first 2 or 3 years of college, there were many times after a quarter ended where I would look back and ask myself this question. Okay, now I have learned something. I learned this, I learned that. Where and how do I use it? And until you build a certain foundation and then start doing some simple hands-on projects, you will suddenly realize, oh, okay, this knowledge can be used here. It will help me solve this particular problem. Therefore, becoming a firmware engineer requires a long time of accumulation and experience. Another challenge is that being a firmware engineer requires a lot of patience. As I mentioned before, unlike software, firmware usually does not have a user interface. So many things on the hardware are not as intuitive, which brings a lot of problems to debugging. So during debugging, we need to use a multimeter to measure whether the voltage and current are stable and correct. We need to use an oscilloscope to monitor the behavior of the circuitry. And then we need to use a digital analyzer to observe if the data sent through the communication channels is complete and correct. So many times just identifying where the problem is takes a long time. We need to continuously analyze the behavior of the firmware, propose some kind of hypothesis, continuously simulate it in our heads, and then verify our hypothesis on the actual hardware again and again until the problem is solved. So this actually requires a lot of patience. Well, although being a firmware engineer means that there are many challenges we need to face, it also comes with many rewards. So the first reward is the sense of accomplishment from solving the problems. Since we face many challenges every day, some problems can even trouble people for a really long time. But when you suddenly came up with a solution one day, implement it, and then see that it actually works, that sense of accomplishment is very strong. You'll feel that your efforts have paid off and you will gain recognition from your colleagues and managers, and that's just how people grow. While speaking of a sense of accomplishment, another source of satisfaction for firmware engineers is the physical products. So firmware engineers work on physical products. You can see the code you write eventually becomes products that help people and make an impact in the real world. You get to see them in action. So maybe next time when you are walking on the street with a friend and a car passes by, you can just say to your friend, so, hey, you see that car over there? It has my work in it. This sense of reality is very fulfilling and allows you to truly feel the value of your work. A joke that we always say is like, when we look at the products we create, it's like we're looking at our own babies. And another thing for me personally is I think what I do is in some sense very noble because we're actually saving lives and protecting the environment. Although major accidents have become more and more rare with technological advancements, but once they happen, they will cause irreversible damage to the environment and to human beings as well. So we are there to ensure that these things will never happen. And no matter what you decide to do as a firmware engineer later in your life, I'm sure you'll be proud of yourself. So here are some final takeaways. Work hard. You need to really put in the effort to accomplish anything. Well, I know it sounds cliche, but to become a firmware engineer, it takes a lot of knowledge from different fields, and it's not an easy task. Same thing if you're going to other fields. Work hard, but at the same time, be patient. Don't rush. You don't want to stress yourself out. So just focus on one thing at a time and move forward at a very steady pace. And at some point, when you look back, you will find out that you have mastered many, many skills, and they all have become your second nature. So when you're able to combine all these different skills that you have learned, you will achieve something bigger. And the other thing is, always be ready to embrace changes. The world is changing at a very fast pace right now. Who would think that the AI would be advancing so quickly? AI has already entered every aspect of our lives. Even I myself took a little bit help from ChatGPT when I'm preparing for the speech. So people might even start to lose their jobs. And the only way to succeed in such a world is to embrace the changes and to harness them. Do something that's unique and irreplaceable. So finally, I want to thank you all for coming and listening. I hope you have learned something today, and I wish all of you success in your future.
Thank you so, so, so very much. Does anyone have any questions that they would like to ask our guest speaker? No pressure, but while we have them, please feel free. Okay, last chance for
Well,
questions.
that must have made points very, very clear.
Yeah, exactly. I think you just did a very thorough job. Excellent. Well, thank you so much on behalf of the Leadership and Innovation Lab for coming to talk with us.
My pleasure.
You've taught me a lot for sure. And so our students and people who are hoping to have that career someday, I know you've helped them a lot. Oh, it looks like we do have a comment. What programming language do you use?
So for my work, I primarily use C, but then I also do write Python scripts. So there's a difference. So for the C programs, they are the actual program that's running on the circuit board. But then I do also use Python to help me write repetitive code or to do some automation. So I primarily use C and Python.
Great.
Well, just because Python is so easy to use. You can do very fast prototyping just to achieve something and use Python real quick. So
Yeah, I think a lot of
and
students tend to have Python.
yeah, and then for everyone that's trying to learn programming, I would definitely recommend Python as the first step or the first language to learn because it's so simple.
Great. That's awesome advice. Sharmi, did you have more questions or anyone else? If you find that you have one, you're all more than welcome to contact the Leadership and Innovation Lab, and we will try our best to answer those questions, not on the spot. So thank you so much again, everyone, for joining our webinar, and your participation is much appreciated.
Thank you.
Take care, everyone. There we go.
All right.
How was it? Okay.
Yeah.
All right.
Once I get started, it feels